Okay, here we go with problem 5, the traditional vector, adding to vector problem. So we have this 17 foot per second, come on pen, 17 feet per second vector, 32 feet per second vector. We've got angles given for both. They're drawn tail to tail here. I'm going to work this problem adding as components, but if I were to draw it as work it adding with trig, I would have to draw them head to tail. So it would be something like 32 at 55 degrees. Okay, then I take my second vector and go 17 at 25 degrees. Okay, and the result, or the addition of these two, would start at the tail of the first, go to the head of the last. So that's our R vector. That's the magnitude we want to determine. The bit of trickery in the geometry here is to recognize that this angle all the way up to horizontal is the same as our 55. Alright, so this green angle inside the triangle is 55 minus 25, or 30 degrees. Once you've got that, you can use law of cosines to get this R, because you know it's the opposite angle in the 32 and the 17 side. But let's go ahead and work this with components. To set up components, I'm going to do magnitude, angle, x and y. I'll use my standard coordinate system, which have already sort of been given here, and just write the vectors out. So the 32 is at 55 degrees, and that's going to be, if I draw them out over here, it's going to be negative in the x, positive in the y. Okay. This other one's going to be positive in the x, negative in the y. So that's the next one. So we said negative in x, so negative, hypotenuse. X is adjacent to the 55, so we'll use cosine 55. The y we said was positive, upwards. It's opposite, so sine of 55. Okay, 17 is the magnitude of that second vector. It's going down and to the right at 25 degrees. So it's going to be plus 17 cosine 25 minus 17 sine 25. You need to get comfortable doing this fairly quickly. We're going to use vectors all semester long. So the sum of those two, it's going to be R. Okay, this is going to be R sub x. If we add those two up, this is going to be R sub y. So if I do that in the calculator here, hopefully quickly, I'm going to have minus 32 cosine 55 plus 17 cosine 25. That's going to give me minus 2.94. Okay, so that is my x. I'm going to store that in x. I want to come back to that, but I'll go ahead and write it down here, 2.947. And that's got units from our graph over here, feet per second. R sub y, let's do the same calc. Let's see, clear. So it's these two numbers right here, 32 sine 55 minus 17 sine 25. 19.03 028. Alright, I'll go ahead and store that. Don't really need to, but I'll store that in y. Where's y at? Calculator's a little bit hard to read. It's right here. Alright. And then my magnitude is just going to be square root of r sub x squared plus r sub y squared. So, second square root x squared plus y squared. 19.255, or about 19.3. Again, feet per second. That's all we're asked for. We don't need to figure out the direction since it wasn't asked for that. Feet per second. Okay.